All right, so today we're going to be learning about Django Validators, just a way to kind of validate or make sure our data is what we expect it to be, and to use associations. So the idea of creating a relationship between our models. So same thing we did with database tables where we had one-to-one relationships, one-to-many, many-to-many. We're going to do the same thing with our models so that it's reflected in our database. All right, so we're going through an example. I guess we're going to be creating a Twitter app for our Django project. So I already created my virtual environment. I installed Django and Psycho PG2. So that's where my project is right now. Let's get to starting our project. So I'm going to do Django admin, start project. I'm going to call my project Twitter proj. All right, that should create a new folder. Cool. Next up, I want to create my app. So I'll do Python manage.py start app. You guys should be pros at this by now. Twitter _ app. And then I want to create a database. So I'm going to create a DB, call it Twitter DB. All right. So I got those three pieces created. I want to go to my settings file. We got two things we got to do. Our app, we got to add that to our list of apps. So I called it Twitter app. And then also my databases, I want to use Postgres. Well, and I named my database, I think, Twitter DB. All right, so two things we had to do was tell Django what our app is and what our database is. So we did those two things. Cool. Let's go to our Twitter app and create some models. So again, we're kind of simulating Twitter here. So we're gonna go off the curriculum page and create some models for our project here. Let's go with like a user model for class, is it account? Sorry, let me look at the curriculum page, make sure I don't get off track. Okay, so we are creating a model. We're going to call it user, looks like. So user models.model. And then we're going to have a bunch of fields. Just in the interest of time, I'm going to copy over the fields that we have, so I don't need to write them and make typos, which I've been doing a lot today. We're going to add some fields to our user. So I just copied these from the curriculum page. So we have first name, last name. We have the email for the user. We have the age of the user and the account type. So I guess they could have a paid or free account. That's going to be a text field that says either paid or free. So that's the intention we are going with. All right, so as it is right now, there is no validation built in. There's a lot of things that we might want to check. Certain validations are built in. For example, as we saw before, when we create a model field, by default, not null is a constraint for any of these fields. So we're already protected from having like an empty first name or empty last name. Those are things that our database will catch. But what if we want to validate email? Well, in this case, email field is a special field that has validation built into it. So if we try to enter in a invalid email field should check that for us, because that's like that's a standard enough thing where Django users were like, all right, or Django creators were like, all right, email is a common enough field. We're just going to create a special field just to validate that. We also have age as an integer field, and then we have account type as a text field. Now, as we talked about, we have certain restrictions, like we want this to be paid or free. We might have an age restriction, like maybe we want only users that are age 13 or older. Right now, there's nothing preventing someone from signing up and saying their age is 5 or -5 or whatever it might be. So we need to add some validation in here. I'm going to kind of jump on the curriculum page and add our test cases, and then we'll talk about how we actually test this. So if I copy what we have there, we're going to create our tests and see what our tests look like before we get to our implementation. So I'm going to paste this again from the curriculum page. We have 3 tests. We're using the test quick case suite from Django. We have 3 tests here. The tabbing is obviously off. Right. Tab, 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 tab. All right, so this is one of our tests. I need to clean up all these. wish the tabbing were consistent. Let's talk about what these test cases are doing before we get to writing validators. So these test cases are creating users that are meant to be invalid, as in they're breaking some of the rules that we expect. All right, so I finally have my test cases all settled, hopefully. Try catch. So we're using a try except block. Hopefully you guys are sort of familiar with that, but let's talk about it. So this is my first test case. We are creating a new user named Tom Preetz with an email, age 12, and account type 3. In this case, it looks like we want our users to be age 13 or older. So how do we implement this in our model so that this test case will actually operate correctly? What's going on here is we call a method called full clean. This is a built-in method for our model. Full clean is actually going to do 3 things. And this is where, again, reading documentation pays off a lot. So I'm going to go to the Googles, look up full clean in Django, and it's going to get understanding what it's doing here. So creating objects, we're familiar with that. Let's look for full clean. All right, validating objects. That's the section on the model reference that I want to look at. So we're on the model reference page, validating objects. There are three processes that get checked. So we call full clean, and 3 things happen. Model.clean fields it's called. So it's going to validate each field individually. That's what this function is going to do. So if you go through each field in our model, make sure each of those fields adheres to whatever validators we want. Additionally, there's a model.clean method that will check the whole model together. As in, if 2 fields like relate to each other or need to check one another, model.clean will have additional logic in there to, check the whole model to make sure it's valid. Versus clean fields checks each individual field independently. Finally, there looks like there's a method called validate unique. As you might expect, this will check for uniqueness if we have any unique constraints that we are telling our model needs to adhere to. All right, so again, we call full clean. And if you want to look at this, you can dive into full clean. So if I do control click, go to definition. This is what the full clean method is doing. So notice it's going through a bunch of stuff. It's calling self.clean, self.clean fields, and also self.validate unique, just like our documentation said. So again, if you're curious about the code, there's nothing stopping you from actually looking at the code behind the scenes. In this case, full clean summary here is validates our record. All right. If this happens to find an error, it's actually going to raise an exception, in this case, a validation error. And this is what we expect. This is what this test case is checking for. It's expecting that when we call full clean, it's going to get a validation error. That's what we want. And that validation error should have this message in it. So it looks like we need to create a validation that's going to say user cannot be under the age of 13. That's going to be in some dictionary, so we'll need to figure that out. The line right here, this will instantaneously fail our test if we ever get to this point. So the way a try except block works is that it's going to go line by line in the try block. So it's going to try to run this line and then try to run this line. If this line has an exception, it will never execute this line right here. And that's what we want. We don't want to ever get to this point in our code. We want to execute this line and jump to our exception, which should be here. I don't know why this is assert false. Is that a typo? Yeah, that should be assert true. So apologies, that was a typo on the curriculum page. But we want to make sure that this is the message that we get back. All right, so let's go back to our model. If I could find my model. Models. All right, so we want to add some validators to each of these fields and maybe want to validate the whole model together. So first name, let's think about this. What are restrictions we want? Well, we have max length, so we know how long the name can be. That's kind of an automatic validation. We know it's going to be not null. I don't know if we need any other validations there. If anyone thinks of any, let me know. Last name, same restrictions, 255, not null. So I don't have any additional validations I want to add, but if anyone thinks of any useful ones, Porpy?
Quick question. Just looking at the curriculum page and looking at the testing, I don't see those self-fail pieces on the actual curriculum page on the
You
testing.
guys are gonna hate me for this. I just added those in because they were not there before. So if you refresh the page, I should be there. Yeah.
Oh,
Apologies
thank you.
for late ads. But yeah, so previously the self.fails weren't there. So the test cases, in my opinion, were not fully correct, because if you happen to call full clean and they did not throw an error, that would not catch it. So what I mean by that is, if this line weren't here, if full clean accidentally did not throw an error, this test case will kind of just continue, and that's not what we want. We want to make sure we fail our test case. So that's why I added those in kind of last minute. All right, so back to our model. Again, first and last name. If anyone has any suggestions, let me know, but I think those are good enough for what we're validating, just the length and not null. We have another hand raised.
Yeah, I'm just wondering if we should check for uniqueness, like if there's replications.
Uniqueness for the names.
Yeah.
That's a good suggestion, but with the world being as big as it is, like there's probably multiple John Smiths. So I don't think we want those to be unique, because again, there could be two different John Smiths. But you're right, our email field probably should be unique, right? We don't want two users with the same email. So that's a good suggestion. Let's handle that. Let's just go one by one. So this is the email field. We want it to be unique. If we're talking about SQL databases, we'd add a unique constraint. The same thing applies for our models here. Luckily, Django makes it very simple. So if we want email to be unique within all our user records, every field has a unique field. So unique, and you can set that equal to true. So this is going to say this email field is going to have a unique constraint on it. By default, unique is set to false. So again, we can have two users with the first name. That's totally legitimate and may happen. But in this case, we want emails to be unique. So I'm going to add in unique equals true, and that's an additional validation that we're going to have our model enforce. Was there another hand raised there, Porfi? Oh, might have been an accident.
No, I just didn't put it down.
Gotcha, fair enough. All right, so that's one restriction. Again, email field is going to automatically do the hard part for us to validate. We have the @ symbol, the .com or .org or whatever we need. So we're going to trust that email validation happens here. If you're curious, let's see what email field does. Email field, Django. Oops, I'll go to reference. Model reference, there's email fields somewhere here. So again, there's a lot of built-in fields. Email fields, one of them. Email validator. So this is one of many built-in validators. So we look at email validator. Let's see what it shows us. Allows an email domains by default. A regular expression is used to validate whether whatever appears after the @ sign is legit. So we're okay, so it's going to look for an @ sign, and it's going to look for a domain regex. So I'm not fully sure what that is, but I assume it's something something is domain regex. But that's what the validator is doing. So that's a built-in validator that email field is going to use. So we don't need to do anything extra here. Email field is going to do work for us. But let's move on to age. So our first test case told us that we need age must be 13 or greater. How do we enforce this with our model here? There are a couple ways we could do this. So let's do it the manual way, and we can also see that there's a built-in way that can maybe make it easier. So I'm going to create a new file. I'm going to call this validators.py and put that in my app. Not sure why it is in my project file. This should be in my app. Validators.py. I'm going to import something, django.db.core.exceptions. Import validation. Sorry, these imports get tricky. Validators, import validation. All right, I'll deal with that later. Hard to remember all the validators, but I want validator error. So that's an exceptions.
Is it just the first import should be from?
Yes, that is an issue too. Let me just copy it because I make typos too often. So I'm going to have something called validation error. That is what should be raised if we have an error. Thank you, Kat. So I'm going to create a function. I'm going to say age greater than 13 or equal, I guess, make it descriptive. All right, so I'm going to create a function, name it whatever I want, hopefully something descriptive. It's going to take in a value. So let's say age value is what we're going to get. This function is what's going to be responsible for checking to make sure we enforce what we want to enforce. So if we have age value is less than 13, we might want to raise an error. So we'll do raise. So this is how we raise an error, a validation error. And then our error should tell us what to actually display to the user. So here I would raise a validation error. Let's look up validation error to make sure we understand what it takes. Validation error, Django. I'm not having a good typing day. Form and field validation, validators. Let's see if this finds it. Okay, so validation error is an exception raised when data fails form or model field validation. That's exactly what we're doing here. For more information, see this link, model field validation. Kind of going in loops here. Just want to know what this has in it. So validation error, what source gives us. All right, so we can look at the class. I don't think this is going to be too helpful. I just want to know what fields it has in it. So let's see, validation error, source, exception. So it's coming from an exception. So let's see what exception looks like. Exceptions. All right. I'm having a bad day looking at stuff. So exceptions. All right. Let's just continue on. So validation error is going to take in some values for raising this error. So if we look at that, it should look like we want the error message. So let's say user, copy it from our test. User cannot be under the age of 13 is what we should return. So that's what our exception should be. And then we also want to have a dictionary, I think. This would be age and the age value. So this is the error message we should get, and this is the field and the value we got. Is that what we're looking at? Okay, so that's what we want. User cannot be age. All right, let's see if this works. So we created a function that is going to check for us. We need to now hook this function to our model. So for our age field, we specify validators. Again, this is a keyword argument because these fields can take in many arguments like unique or max len. In this case, we want to specify validators for this particular field. So I need to import from .validators, import my age greater than or equal to 13. So this is my function I'm importing. Now I can use that here. This is going to be a list of validators. The important thing, you can have more than one validator for a certain field. That's why I created a list. I'm telling Django, hey, this is a function you need to run on any field when you're validating the data so that age is actually checked. Okay, so that is one validator we're setting. If we want to set more, we could. Like, for example, what if we had a negative age, right? Like I could add another validator saying age must be positive. And then if I wanted to create another function, so let's go with that. And just because I'm lazy, I'm going to make this a star import. So everything I add to my validators will just get imported. Now we need a new function. So if I do def age must be positive, we take in the age value, which we pass to us. And I say if age value is less than 0, I guess if you're equal to 0, that's whatever. If we have babies, I don't know. Let's raise this. Now, obviously, these are going to kind of overlap, right? If we have someone that's age 7, this will be thrown. If we have someone that's age -2, both of these will check. So I think the ordering of that matters. So age cannot be negative. Let's put this over here. And then, all right, so I'm going to switch to ordering because I want the negative or the positive check to be done before the 13 check. So, all right, so now we specify 2 validators. We're saying check this function and this function because we have multiple validations we need to do. So let's run our test case for the first test. I'm gonna comment these out. So we get a message dictionary and we're looking at the key of age. So this age should be coming from our validator right here, where we set the age value here. All right, I'm gonna need to figure this out. So let's see if our test case passes around. So if I do Python manage.py test, let's see if I've hooked everything up correctly. Unhashable type dictionary. Okay, so we got text back. Let's try it. Where are we going here? Validation error, message. What are we looking for? Message dictionary, I think. Tests. E-message dictionary. So that's what we want. All right, so we want to create a validator is valid, raise validation error. So it looks like we want to return a dictionary with the key, the name here. Let's see. Okay, so we return a dictionary, not just text. All right, that makes sense. So here we want to return age as a dictionary. So this is, I think, slightly different from our curriculum page. But age is our key, our value for the error is that. So I think that's what we wanted. So now we return a dictionary where we can look at the key and then get the specific error message. I think that's where our test case is asking for, where we have a dictionary that automatically gets created and we look up the age key. See if that resolves this. Okay, ran one test, validation error has no error list. Let's just do some debugging then. We're going to do a print E, and let's see what that looks like. So we have age, because it's a list there. Dot message. All right, so I'm just trying to figure out what's actually stored in my dictionary. So let's make that really apparent. All right, let's try to find that in my outputs. That can work here. Validation error object has no attribute error list. Okay, let's just go to my curriculum page, see what they're doing. They're returning text. All right, I'm just going to copy what our curriculum page has so I don't get off track here. So validators, we need to return something here. It looks like they're returning text. And this, I'm not sure if this is what we need. All right, text is not even function here. So we need to import. Sorry guys for the troubles here. Not sure why they have this format. So they're importing something called get text lazy, and they're using it here. Let's see if that is what they expect. I don't think this is what we need, but yeah. So right, this is getting worse and worse. I don't think that's right. So I think dictionary was correct. And then our message was here. All right, I think documentation should be the best way to go. So this Stack Overflow didn't do it for me. Django projects. All right, so they have, that's not what I want. Validators, that's not what I want. Validation error, Django. I apologize, guys. Validation error.
Do you have them flipped, except E as validation error instead, maybe?
Let's see. Right here. I think that should be fine. So E, we're aliasing the validation error as E. So we should get E as our variable here. I'm not even sure why this is not printing out is my question here. So their example.
I have a breakpoint set on that one. That except statement does not run. That's where it fails.
Gotcha. Yeah, I think, let's see. Let's just look at their examples. That's probably the best way to go. So we want to raise a validation error with some text and a code. So params. So code is invalid, invalid. So it looks like they're returning text and params. All right, I'm just gonna make this work the way I know how. So I'm just gonna return text. I'm not gonna return a dictionary, and then we'll see what we get here. Why not migrate? Not sure why I'm running into all these issues, but let's migrate. Okay, so we finally passed. This is what we get back. So, okay, so we return text. Sorry for that. That's my apologies. I take ownership of that. All right, so we return text. This is the error message, and it looks like it's automatically tied to the age field, so we don't need to return a dictionary in this case. So we return the error of user cannot be under the age of 13. On the test side, this dictionary gets created for us. So E message dictionary has the age field already as a key. So that is what the value is. User cannot be under the age 13. And that's what we wanted. So we ran full clean. Full clean will go through each field and go through its validators. So if we look at models, it's going to run through each one of these validators for the value of age. And then each one of these functions will run. Age must be positive passed. So it did not raise this error. And let me get rid of this stuff. It didn't raise age cannot be negative because it passed this test. Then it went to the second validator and it ran into an issue here where user cannot be under the age of 13. All right, so if we wanted to see the other test case or other validator fail, we can create a new test case. And what if he had a negative age, which obviously shouldn't be allowed? Let's say Tom is negative 12 years old. We should get another error message here. So user age cannot be negative. Just going to copy this so I don't make a typo. So the error we should expect now is age cannot be negative instead of user cannot be under the age of 13. So this is test number 2. Create user with neg age. See how this runs. Okay, so notice we passed the second test case because when we ran full clean, that validation error that was raised was not this one, it was this one. So the ordering again matters here. If I swapped the order of my validators, now my age greater than or equal to 13 validator would run first before age must be positive. So if I make this change, my test over here will no longer work because this will not be caught because this test kind of will catch the same thing, right? We're checking less than 13. So we have negative 12, that is less than 13. So this would be the error raised instead of my negative 1. So I ran this, okay, that still passed. Why did that pass? Print. print. Let's see what order these actually get executed in. So it looks like it tested other first and then tested here first. Why would that be the case? Page is doing alphabetically. That would be really silly. If it is, then I kind of just give up with validators, but page model. Let's see if it's doing alphabetically. Yes. All right. Let's migrate again. Page must be positive. Where is this getting this from? Oh, is it from my test? All right, I'm just gonna forgive this. This is not going well. So that's creating validators. So we create more than one validator. Let's clean up my mess here. Let's go to account type. So account type wants to be paid or free. So we can add another validator here, and that's gonna be validators check valid account type. And we do the same thing where we go to our validators file. We want to create a function called check valid account type. Define that, takes in the account type value. And we do the same, we do whatever check we want to. So we'll do if account type value not in, and our valid items will be free and also paid. Okay, so if it's not one of these values, we want to raise a validation error, and we should match our test case. So our test case is looking for user, that's what I want. Please enter a valid account type. So I copy that for my validators. That's what we want. So please enter a valid account type. Otherwise, we should be fine. And then let's go to our test case. So they have account type free. Why would that not be valid? So let's say they have a bogus account type. Let's just say donut. So if they have a donut account type, we should see the error message of please enter a valid account type, because our only valid ones are free and paid. So let's see if this achieves what we want. Test that. Yes. Okay, so we ran 3 tests, we passed them. I have some erroneous output here. Still curious what order you may do it. I thought it'd be the order of the list. All right, so we ran 3 test cases. Since they did not have a free or paid account type, this raised an error. Please enter a valid account type. If we want to see our test actually fail, so we had free here. That should be a valid account type. So here, new user full clean would not raise an exception. So we'd fail this test case because we're not raising an error. John, you have a question, comment?
Just a request. Can you see when you're doing your test if new user is none? Because that's what I'm getting on my side, and that might create issues when you're trying to do your try clause.
Are you saying this new user is none?
Right. So it doesn't initialize because it's throwing the error there.
Oh, when I use donuts here?
Or just anywhere. I'm still looking at the first test case, but any of them.
It should create it. So validation is not automatic. So that's a good point to bring up. When we put in bogus values here, it's not automatically validated. It's only validated when you call full clean. So John wants us to check user. So we'll do new user. Let's make it obvious. It gets there. All right, so I'm gonna run my test suite again. All right, so we failed on a self.fail right here because this did not raise an exception, but we did get the user object. So I'm not sure why you might be not getting a valid user there. Make sure you're running a test suite because that'll create the database and the records for us in this case. Okay, so that was kind of painful. I apologize. But the takeaway here is we can add custom validators. So in this case, we need to do something special where we need to check a specific account type where it's free or paid. We create the validator. However, Django has built-in validators. One validator that we kind of talk about is email validator. Another one is actually, there are greater than and less than validators. So if we look at Django documentation, obviously I need to find it. So Django validators, perfect. So notice there's an email validator. There's also regex validator. We'll see that in a second. There's a URL validator. So again, common behaviors, they have validators for them. But notice there's also a min and max value validator. So instead of creating my own, I can kind of leverage what Django already has for some of these. So, I think min value makes sense because we want to check a minimum value. So here, instead of creating my own, I could import from Django.core.validators, import min value validator. So again, this is a built-in validator. It's going to do kind of what we expect. If we're not sure, we could read documentation. But here, we call min value validator with a value. So in this case, 13. And let's see if that does what we want. So that's going to fail if we don't do this correctly, but I'm not sure how the error message is going to be displayed. So let's actually print out our error message here to see what we get. Because it's not going to be, we can maybe customize error message, but I just want to see what the default one is. So clear here. Run Python test. Oh, I think I need to make this focus. Okay, so ran 3 tests. What do we get? So this is the default error message you get. It says ensure this value is greater than or equal to 13. That is not something that we are expecting. We want it to be user cannot be under the age of 13. So I'm pretty sure there should be a way to override that. Now the question is, how do we do that? Let's look at min value validator. So message. So notice that message is a parameter we could specify. If we don't specify it, then it's just going to be the default value. So in this case, we want to override message to be exactly what we want it to be. So limit is obviously the limit we care about for the min value. Message is what we want here. So message is going to be exactly what we want it to be, which is user cannot be under the age of 15. Copy that over to our models. There we go. So now if there's an error thrown by this validator, it's going to use our message rather than the default message of ensure this value is greater than or equal to 13. Let's get to testing and see that that passes or get her. During handling, dictionary object has no start test. Where the hell is that coming from? What? Did I screw something up here? Oh, sorry. I was doing self instead of print. That is totally a typo. All right, so there we go. So now we're still getting the same error message back, but we're using a built-in validator. So models, we're using min value validator, where we're specifying a custom message. So again, use built-ins when you can, so you don't have to create your own, but sometimes you can't use a built-in, right? For account type, we need to specify like paid or free as exact values. So we want to use our own custom validator here. Okay, that's kind of an intro on validators. We're going to have one more example, which I'm more familiar with, which is our student and school example. But let's talk about relationships now. So we have validators. Let's kind of switch gears and go to an example we're more familiar with. So I'm not going to create a new project because that's going to be a waste of time. I'm just going to create some models though. So let's create a professor model. So we're switching to our school example. Sorry for the quick transition from Twitter. What we need are models, not models. All right, so let's create a professor model, models.model. That's going to have some fields in it. So let's say they have a name. It's going to be models.char field, and that could be max length 32. We can have additional fields, but the real thing is, how do we create a relationship between courses, which is going to be another model here, so models.model, and professor. So let's say a course has a name, it'll be some name. Let's make this first name to distinguish it. All right, so course and professor is going to have some relationship. Again, this is the same thing we did with schema design. What's the relationship between courses and professors? Well, can a professor teach more than one course? For our school example, I think yes. We're not going to limit a professor to just the one class. Can a course have more than one professor? In this case, I'm going to say no. We're just going to have one professor per course. So given that, we have a many-to-many relationship. And if you remember from our SQL days, we need to create a foreign key relationship. We need to do the same thing in Django, where we need to associate our course model and professor model in some way. And luckily, there is a pretty easy way to do that. So we're going to create a new field, call it professor. We're going to make this a models.foreign key relationship. So models already has a foreign key field type. In that, we need to specify some parameters. The first value needs to be the model we're referring to. So in this case, professor is going to refer to the professor model. So I'm going to type in the professor model. Important thing here is the ordering of these two matter. Since we are referring to professor here, we need to define a professor class first. Next thing is we need to have an onDelete method. So this, we're going to make it models.cascade. I feel like this is something we lapsed over during our SQL week. So basically, your onDelete method for your foreign key is saying, hey, if the corresponding record in the professor's table gets deleted, how should we handle the record in courses table? Meaning, if we have a course taught by Professor X, and Professor X, gets removed from our data, should that course still exist in our course table? Models.cascade, or sorry, the cascade method for onDelete says, if Professor X gets deleted from our professor's table, the corresponding course that refers to it should also get deleted. That's what cascade is saying. There are other methods we can use. For example, restrict is another method. This will say, if we attempt to delete Professor X from this table, we should actually get an error saying, hey, that operation, you cannot delete that professor because there's a course that relies on that professor. So the behavior that you want is what the onDelete property is setting. Most of the time, I always go with cascade. Just if I'm deleting one record, I want the rest of the records to be deleted. So that's what the deletion type here. There are other types too, but cascade is going to be the most common for our use cases. Restrict might be another one you might see. So these two parameters are required: the name of the model, and then the delete behavior if the corresponding record gets deleted. The optional but highly recommended parameter is related name. This is how we're going to actually refer to this relationship from the other side. So for courses, we have a field called professor. We're creating that field explicitly. This related name field is going to kind of create an imaginary field right here based on the name that we give it. So in this case, I'm going to call this courses, meaning if I have a professor instance, I should have access to a courses field for that professor. And this would contain every course that the professor is in. So this is a little different than SQL, where we don't want to have an array as a data type. Django kind of automatically creates that data for us. This is not stored in our database. This is going to be a foreign key field in our database. But when we get into Django, the conversion creates another field in our professor model that's going to have every single course that professor is responsible for. All right, so this related name field is optional if I don't provide it. This field by default will be like courses, course sets, I believe, is the Django default naming. So you don't have to tell Django how to name it. If you don't, Django will have a default way to name it. So I think in this case, we'll use the model name underscore set will be the way to access it. All right, but I prefer related names. So I'm going to specify I want that field to be called courses on the other side of this relationship. All right, so if we create these models, I think I need to make migrations. So let's do that. Python manage.py make migrations. Okay, and then we want to migrate Python manage.py migrate. Okay, so they should have created 2 models for me. Now I'm going to create kind of a data seeds file. So let's go to my projects, sorry, my app, do data.py. Here, let's create some data records. So I'm going to import from, I guess Twitter app is still what we're calling it, .models, import our professor model. Want to import professor and course. All right, so if we create a new course, let's do course equals course name equals CS101, and then professor, we need to refer to professor in some capacity. So in order to create a professor link, we need to create a professor record first. So I'm going to create a professor and call it professor. First name for that professor will be, I guess, Professor X. All right, and then we need to save it. So again, this is what actually adds it to the database, save. Then now that we have this professor saved, we can refer to that professor here. So we're setting the actual object, not the ID. Keep that in mind. Normally for SQL, for database tables, we reference an ID. Here we can just reference the object and it should work fine. And we want to save this. Let's create one more course. So we'll do C1 and C2. C1, C2. Let's make this Arts 202. Top of the same professor. We'll do C2.save. All right, so we're creating 2 new courses, CS101 and Arts 202, and we're going to save them to the database. Next, we want to retrieve these records from the database. So actually, we don't need to retrieve them. We have the professor here. So if we did something like C1 dot to print C1 dot professor dot first name. So notice how we access these values. We have C1 is our course. Professor should be a field on our course. And then that professor has a first name through the professor model. So we should be able to see course, say CS 101 prof. And then what if we want to see all the courses that the professor is teaching? This is where that related name field becomes quite handy. So we could do something like Professor X courses. And then we could do professor dot courses. Now keep in mind, in our models, we did not explicitly have to create this courses field. This foreign key creates these courses for us, this courses field. So if I ran this data file, if everything worked correctly, we will save one professor, save 2 courses, and to be able to see either using the professor field from the course side to access data and the relevant to the professor, or if you want to see, from the professor side, what courses are they teaching, we could reference the courses field. Probably want to add in an str method just to see some more information here. Was there a hand raised like a second ago, Rob?
So Ankur, are validators essentially just like a check on the input data going into a SQL to make sure it's clean? Or like,
yes. You want to, so this is where we get to like the multiple layers of protection. So our database is going to have some protection on it. Our server also should check before attempting to insert anything to the database. We should check ourselves to make sure we are adhering to whatever restrictions we want. And then also on the UI layer, if we had a form, we should also be able to check on the form and check as soon as possible and return any errors to the user at multiple levels. So yeah, this is checking before we insert to the database, make sure our data is clean. Was there another hand raised there?
Yeah, thanks, Uncle. So when we create these models in Django, anytime we do a foreign key, it's gonna implicitly create a field in wherever we're saying the foreign key is.
Yep.
And if we don't do related name, it's just gonna do whatever the name of the model is and then underscore set.
Yep, you got it. So
And it's
we
a-
explicitly create one side of it. We create the foreign key relationship in courses. Django automatically will create a field on the opposite side based on that foreign key. So it makes it convenient so that we don't have to go through the courses to determine, hey, which classes are Professor X teaching? We can just do that straight from the professor record. So I have
So
my
is this a
data
list?
file. I'm going to run this file and let's see if we get what we expect. So if I run Python manage.py shell, feed it my data file. So that's in Twitter app/data.py. Let's see if that runs. Okay, notice what we got back. We got CS 101 professor is Professor X, because we're showing the first name of the professor. Again, keep in mind, this is the foreign key field, but we have access to all the records from the professor model. So again, this isn't just an ID. In the database, it's going to be stored as an ID. So if we look at the course one model, we look at the course one table in the database, this will be stored as an ID. It's not going to be like the full professor record. But Django just makes things more convenient. Instead of forcing us to kind of look up a professor by ID, it's going to give us the whole object back here so that we can access whatever field we want off the professor. Notice we printed out Professor X courses. We got none. That is not what we want. P save courses. Twitter app course none. Save this, save that. All right, curious why that is none. But was there another question out there?
I had one. So because the way that related, it can show like professor can show all the courses. Does this mean that in a many to many relationship, another table doesn't have to be created? You just need them to both be related to each other, and you can get the answers for stuff.
We can create a many to many relationship. We still need that join table. So the SQL part does not go away. Sorry, I want to figure why this is not working. So courses should be right. So data p.courses. Let's look up our professor. So p equals professor dot objects dot get pk equals p dot id. And let's try this. I wonder if it's not updating. So I'm going to get the professor back from the database and see if their courses now are updated. Try that. Twitter app course.nut. Why do we have no courses here? We have foreign key, cascade, related name, courses. So, okay, this should have the courses that the professor is in charge of. I'm not sure why that is failing here. px.courses. Let's try for let's take a look at the database. Maybe that's a good place to start. So if I go to /d, let's delete all of our data. So we'll do professor objects all delete, and we'll go to courses. Course.objects.all delete. All right, let's try running our data file. Okay, we're at course none. And I want to check my database. So I'm going to go to pSQL, Twitter, DB. And then let's do a select star from Twitter app courses. All right, so we do have two courses. The professor ID is 4. That seems fine. We do a select star from Twitter app professor. So that is linked up correctly. Why is PX courses not giving me what I want? Let's try course set. I wonder if that's going on. Nope, doesn't exist. Courses. Why is that blank? Anyone have any ideas? Obviously, this should. So that exists, but it's not tying it together. Foreign key, professor, on delete cascade. All right. Let's try iterating over it. Maybe there's something. So Twitter app course none. What if we did for course and PX courses? Right. See. Related manager option. Oh, I know why. This should be all. So we need to do courses.all. See if that makes a difference. There we go. So we need tack on adapt.all. So courses is not just a list. We need to do a query, Django query on it. So .all will give us access to the courses. So notice we get a query set with 2 courses in it. And if we loop over it, we should get CS 101 and 202. So it is stored in there. We can't just do .courses. We need to do .courses.all to get to it. All right. So I have the school example coded up, and let's take a look at this kind of validators and everything coming together. So I'm going to do a copy and paste because we're running short on time, and paste a bunch of stuff in here. So this is going to be, again, our example from last week where we have a locker, we have student record, we have a professor record, professor model, course model, and an enrollment model. So going to see kind of all these pieces come together, and let's see if we can understand this. So I have a custom validator. Gonna go to validators, drop this in. All right, let's talk about this example. I know we didn't spend time typing it, but we want to make sure we understand it. So taking a look at our locker example, hopefully you remember from last week, we're gonna have a locker number. We want that to be unique. So that's, again, a constraint we could set. We have a locker combination. Now, if you keep in mind, we have a particular format we want. Our combination should be like 10, 20, and 30. There should be a number, a dash, a number, dash, and a number. That is what combination we want. So again, if you're just remembering those, like those old master lock combinations that you turn the dial, that's what I'm thinking of. So here I'm specifying a custom validator. Here I'm saying validate locker combination is what we check. So if I look at validators, I'm doing a regex check, but I'm also doing another check for valid digits, right? So the turn dial doesn't have like infinite numbers. I'm going to say that turn dial has to be between 0 and 60 or less than 60. So I'm going to check 2 different things with one validator. I'm checking if the format's incorrect. So we're looking for a particular pattern. In this case, digits, either 1 or 2 digits, dash 1 or 2 digits, dash 1 or 2 digits. And I'm also looking for a valid range of the numbers. So if I don't get a correct match, that means it's an invalid format. If I don't get valid digits, that's invalid combination. And then in either case, if I have an error, I raise a validation error. What else do we have? So we go back to models. We have student. We're using a 1-to-1 field. So this is another relationship we can have. Django has a pre-built field for it, where I specify each student should have at most 1 locker, and each locker should have at most 1 student. That is what 1-to-1 field will take care of. So again, this just makes it easier than doing it in SQL, where you gotta create a foreign key and then a unique constraint. 1-to-1 field will do the work for me. Notice I also have related name and the deletion method, also allowing null in this case. I'm saying a student doesn't have to have a locker. Taking a look at our professor model, nothing too interesting here. We have first name, last name, start date. No other relationships directly applied to professor. But from our previous example, course is going to have a foreign key to the professor model. So in this case, what we did before, where we have courses as the opposing set or opposing field here. So you can imagine that there's courses accessible on the professor side. One new thing right here is the many-to-many relationship. So this is a third type of relationship. We talked about one-to-one, where we use simply a one-to-one field. We talked about foreign key, where we use the models that foreign key relationship. Here we have many-to-many. And this one has some details we need to talk about. So here we have a separate join model, or I guess a join table, where we have enrollment, where we have student and course as foreign keys, and then grade is additional data that we have here. Because we need to store additional data, we have to create this model manually. So that is why we create a many-to-many field here. And we say we're going to go through the enrollment table because we have the join model created already. The nice thing about Django is, let's say we did not need to keep track of grade. Let's say we just needed enrollment to tie students and courses together. We, in fact, would not need to create this model at all. We can omit this model and say, we're going to have a many-to-many relationship like this. This will take care of creating that join table for us. So that join table still needs to exist in SQL or in the database, but we do not need to create a join model for Django's sake if we don't have any extra data. So many-to-many field will take care of what we need. But in this case, we do need to keep track of something extra in our enrollments table. And the only way we can do that is by creating a new enrollments model to keep track of grade. If we did not need that, we can just use the many-to-many field and Django will sort out the rest. So I'm gonna run this and let's just kind of see all the validations in play. So for my grade validator, I created a regex validator. So this is another built-in validator where I want the grades to be explicitly either A, B, C, D, or F, and either a plus or minus optionally. So that's what the question mark means. If you remember our regex syntax, this is saying these are the only valid values you can have. I could have A plus, A minus, I could have A, I could have B, I could have C, C minus. E would not be valid, right? Because E is not part of my character list right here. So that's what this regex validator is going to check to make sure I input a valid grade. Now we're hitting lunchtime, so let's kind of get this example going. So if I clear this, let's do Python manage.py create super user. Age must be positive. Where is it getting this from? All right, maybe I need to migrate. So make migrations. I forgot to do that. All right, you know what? We're just gonna get rid of these. Obviously, I should create a new project. Let's drop my database. Let's create my database. Let's test. These don't matter. Models. Okay. So I dropped my database, create a new one just because I think it was confusing me with the previous example. Let's do make migrations. So Python manage.py make migrations. Fingers crossed. All right, there we go. So we're creating 5 new models: locker, professor, student, course, and enrollment. Then we want to migrate. So we do Python manage.py migrate. All right, it ran all the default migrations. Now, once we have migrated, we can create a super user because that super user has to be stored in the database. So Python manage.py create super user. All right, we're gonna go with admin. Edgar, you have a question?
Yes, if you did want to, like, I know Django creates like a primary key automatically, right? You don't have to declare it.
Yep.
In the model. So how would you reference that if you wanted that to be, like, if you wanted to be referencing that, would you just say like related name equals ID or something?
Yeah, so want to make sure we understand these pieces. So by default, when we create a foreign key relationship like this, right here, in the database, this record is going to be the ID of the professor. It's not going to be the professor record.
Okay. This
This related name is purely for Django's sake. This is not referring to any other field. This is just creating a kind of imaginary field on the professor side. So what, again, we're referencing an ID, but if you remember from our example on Friday, we don't have to reference the primary key. By default, foreign key is going to refer to the primary key of this model. Well, let's say for our locker, if we didn't want to reference the locker ID, but wanted to reference the locker number, because that is also unique, we do have the capability to specify that within here. For exact syntax, I think it's like fields. I think field and it'd be locker number. I think that's how you do it. There's a way to do it. I'm not familiar right offhand, but you can say instead of looking up the primary key, specify the exact field that this one-to-one relationship will be made on.
Okay.
So there's a way to do it. I am positive of that. But for now, I'm just going to default to the primary key just because it's easier. All right, so we create our super user. Let's get our server running so we can see this in action. Python.manage.py, our run server. Okay, server seems to be good. We need a browser window. There you are. Okay, so we go to our admin panel. Log in with my super secret login. All right, so notice I don't have my models here. If you guys remember, we need to register our models. So that's a step I did not do. So I need to go to my admin.py file in my app folder, and I need to register my models here. So I'm going to do from.models, import everything, and then I'll just register everything. So I'll do admin.site.register, pass it a list. So we had locker, students, professor. What else we had? We had course and enrollments. Keep in mind here, this means import everything from my models. So these are the 5 models I want. All right, so let's see if I refresh here. There we go. So we can add some information. Let's kind of do this quickly. So lockers, add locker. This needs to be a number. So it's gonna be like locker 101 combination. We had a validator on this combination, right? So if you remember, my validator returned these error messages: invalid combination format with a bunch of exclamations, or invalid combination digit. So we need to be between 0 and 60. So what if I had a bad format? What if I did like 55 -- 4 and then X 55? This is not a valid format. So if I try to save it, let's see what happens. Notice we get an error message. It's the error message coming from the validator. So your admin panel kind of hooks into the validators and reads the error message. Notice I get the appropriate response. If I do like 10, 20, and 99, 99 is not a valid digit. So if I hit save now, notice I get that error message. So that's kind of cool that you can kind of see the error messages sent back to the front end. Again, this is through the admin panel. We need to do a little bit more work if we did this through our own form. But we can create, some lockers, save here. Let's create a couple more lockers quickly. 102, combination will be 111, that's valid. Let's create one more locker. 103, combination will be 4, 5, 6. All right, we have a bunch of lockers. Let's create some students. So 0 students, we can create Anna Abrams. Birth date will be today. Notice that the UI provides all the possible lockers for us. We don't have to type in the locker. The UI is kind of being nice for us. So let's say Anna gets locker 101. Hit save. Cool. Anna got added. Let's do Bill Burr. Birth date is today. Let's try to add locker 101. Will this allow me to add locker 101? Yeah. Remember, Anna is already assigned to locker 101, and we have a one-to-one relationship between lockers and students. So if I try to save this, notice we get an error message. Student with this locker already exists. So that is what the one-to-one is checking. We already have Anna assigned to locker 101, so we cannot reassign locker 101 to anyone else. That locker is taken up. So let's give locker 102 to Brian or Bill. There we go. We can do professors. I don't think we had any validators here. So let's just say Charlie Chaplin. Start date was today. Okay, if we have a professor, we can create courses. So we create a course, CS 101, credits. So let's think about credits. Does it make sense that can we have a course with 12 credits in it? That's probably not a real course. I think most courses are like 2 to 6 credits. So we might want to add another validator here. So let's do that quickly before we save this record. So if we want to add in a validator, I'll go to my models. So we didn't go through all these fields, but credits, I'm thinking 16 is probably a lot. So we have the validator set here where we have min value validator as 1. So that's our minimum 1 credit course. I've had, I guess, a 1 credit course. We're saying the maximum credits a course can be is 6. So this is, again, using the built-in validators so that if we try to save this course with 12 credits, we should probably get an error. So let's add Anna and Bill to this course. All right, if I hit save, let's see what happens. All right, this field is required, blah. Notice we get an error here. That's because of the validators are being checked while we try to save this form. So let's make this 4 credits, hit save. Okay, so we got the course. Let's actually take a look at enrollments. So no enrollments here. Want to add enrollments. Say Anna is part of CS 101. Her grade is E-. Is that valid? Well, let's see. Nope, not valid. What about F+? I don't know if F+ is a real grade, but let's just say it is. Based on our validators, let's go with B+, more sensible. All right, there we go. So we got an enrollment where student Anna is paired with course CS 101. Her grade is B+. If we look at another restriction we might want to have, well, can we enroll Anna into CS 101 again? Well, let's try going with Anna is going to be re-enrolled in CS 101. Let's say her grade for this enrollment C-. Notice we get an error. This is another restriction we have in our model. Enrollment with the student in course already exists, so we're not allowed to enroll the same student in the same course. How is that achieved? Again, a lot of this you're going to get familiar with. In this case, we don't want a unique key on this value, right? We do not want to set unique here because this would mean that Anna can only show up once in enrollment. She can't be in multiple different classes, which is not what we want. True. So this is not going to accomplish the uniqueness that we want. Likewise, if we have unique equals true here, it's going to say that, you know, CS 101 can only show up once in the enrollment table. Again, that is not what we want. So instead, we create this restriction. Class meta is a reserved class name that Django is going to look for. So must be named meta. This is not meta Facebook. This is just a meta class. Django is going to particularly look for class meta and look for a unique together field name. A lot of this is from documentation, so understand a little like, hey, don't really know where this is coming from, but this is the way you can pair fields together to make them unique. So as you saw in database world, we add a unique constraint for multiple fields. The same thing's going on here where we're saying student in conjunction with the course field have to be unique so that we can't have the same student enrolled in the same class more than once. All right, so again, this is a decent example of using built-in validators, using regex validator, using custom validators, which we saw for our locker combination. Additionally, we're showing how we can use one-to-one fields, which take care of the foreign key and unique restrictions. We can create a foreign key, which creates a one-to-many relationship. Again, the related name gives us access to that field from the opposite side. So again, keep in mind how we name the related name. Since I'm creating this foreign key in the courses table, my related name is courses, so that professor has access to courses. Likewise, in my enrollments table, I have related name enrollments for both the student and course fields. This just means if I have a given student, I should have access to a field called enrollments right here. All right, so it's another field Django is going to automatically create for us. I'm not going to manually create enrollments. This relationship of foreign key will create that for us. I had another thing here. I think related name would be courses. This is a many-to-many field, but instead of going through the enrollments table, I should have access to something called courses for students also. All right, because this many-to-many field establishes the opposite side of the relationship. So I'm saying here, course has a students field, plural, because this is a many-to-many. So a course can have many students. Likewise, a student can have many courses, but I don't need to create a courses field here. The many-to-many from the courses model will create that for me. All right, I feel like I've been talking forever. I want to pause for questions and then we'll get you guys to lunch. What questions you guys have about validators or associations, those one-to-one, one-to-many, many-to-many fields?
So I was wondering, when you do the unique together student and course,
Mhm.
It's looking at the classes, it's not looking at fields inside of the, oh, okay, so you have it inside of enrollments. Student
Yep,
course.
yeah,
Gotcha.
so enrollments has a student field and a course field. Again, back in the database, these are just gonna be IDs, but in Django, they'll give you the actual object, which again, makes it very convenient. Because normally you don't want just IDs, you want the full information about the student if you want to get to that information. Andrew? Andrew Trent? Not sure if you're muted.
Yeah, sorry, I was muted. If you do the mini field and you don't have any new information and you said we don't have to create a new class.
Yep.
Is that actually in our database?
Yep, good question. So let me do this for example. This is not gonna make sense. Let's just say donuts equals models many-to-many with professor. That's not gonna work. Let's go with lockers. All right, this makes no absolute sense why you're mapping courses to lockers, but if you did this, and let's just say we have the many field, related name would be courses. So somehow courses and lockers are tied together. No idea how. If we did not want to create another model, we can run this and make migrations. So let's see, Control C. Hopefully this won't yell at me. Make migrations. All right. So it's going to alter the students table, add a field donuts. That's fine. Let's migrate and let's actually take a look at our database because it is important to understand what Django is doing for us. I'm going to migrate. Cool. Let's dive into the database quickly. I think it's so-called Twitter TV. Let's do definitions. Let's see all the tables created based on our models. So I'm going to get through all that stuff. All right, so all these tables down here are what was created for my apps. Notice that each model has a corresponding table. So we have course, we have enrollment, we have locker, but we just created a new many-to-many relationship between courses and lockers. Again, not really sensible, but let's take a look. So we have a locker table, we have a course table. Notice right, where is it? Right here, we have a new join table called course donuts. This is the join table for courses and lockers. Obviously, I didn't name it really well, but this was automatically created for us, even though we don't have a donuts model, right? I do not have any sort of donuts model right here, right? But this many-to-many field, we still need that join table. So understand that there's no way to solve the many-to-many relationship without a join table. So that join table was created automatically by Django, and that information can be stored in app course donuts. But we did not know how to create that model. For enrollments, we did how to create that model because we want to keep track of additional data. In this case, grade is something additional that the enrollments table is going to have tied to it. So yes, that join table is automatically created for us through the many-to-many field if we do not want our own model to keep track of any additional data. Yeah, it's going to take some time to kind of understand all the Django stuff that's going on, but know that this is meant to make life easier so we don't have to worry about joins as often. Again, foreign keys and one-to-one fields kind of have everything much easier for us. Again, foreign key fields give us the actual object, not just the ID. That's really beneficial. Okay, any other questions about validators or associations?